In other screencasts, we have looked at how Eiffel events work on a conceptual level. How can they be used? What value do they provide? How do they relate to one another? In this screencast, let's take a look at how that works in practice. Let's take a look at a simple example of an Eiffel event. The Eiffel confidence level modified event is used to signal that something, typically an artifact, has achieved some level of confidence. Let's say the latest version of your login service has passed acceptance tests. Every Eiffel event is a typically fairly small JSON document. It consists of 3 top-level objects. The first part is meta. This contains meta information about the event and common properties shared by all event types. The most critical properties in the meta object are the type, version, time, and ID. The type property declares which type of event this is. In this case, it is an Eiffel confidence level modified event. This is important because every type of event carries a different meaning, has different properties it can or must define, and has different ways of referencing other events. We'll get back to that in a minute. The version property does what it says on the tin. It declares the version of the event type. In Eiffel, versioning is done on a per event basis, so you might be using version 1 of one type and version 15 of another in parallel. Type and version are the 2 properties that any consumer of the event needs in order to make sense of the rest. In theory, everything else in the event may change from version to version, but type and version must always be present in the meta object. The time property is milliseconds since epoch of when the event was created. If you are familiar with the concept of event time skew and the difference between processing time and event time, then this represents event time. If not, then think of this as when this thing happened. Next up is the ID property. This is a UUID identifying the individual event. This is what we'll use to reference this event from other events and is useful when querying for events in databases. The source property essentially answers the question, where did this come from? It can be made more or less detailed, depending on how strict one wants to be about this. This example only declares the originating domain. A domain is an infrastructure topological concept that can help you organize your event producers. The meta object contains more optional properties, for instance, letting you attach custom tags to the event, but we're going to skip those right now. You can read all about them in the documentation. It is important to note, however, that Eiffel makes extensive use of optional properties in the event definitions. This is because the perhaps most important design principle of the protocol. What to communicate is volitional, how you communicate it is not. So if you want to be very explicit about exactly which host this event originated from and which software was used to serialize it, then there is a way for you to do that. A way that consumers should understand without you having to coordinate and handshake syntax with them, or they can just ignore it if they're not interested. On to the data object. The data object contains the payload of the event. Its properties are always specific to the particular event type. In this example, there are 3: name, value, and issuer. What is the confidence level we're talking about? Was it successfully achieved? And optionally, who issued it? Obviously, these events are typically the result of automated processes, and if a robot generated the confidence level, it may or may not be very relevant to identify the issuer, but Eiffel is designed to seamlessly integrate both manual and automated processes. After all, it's not the consumer's concern how the producer came to the conclusion that acceptance tests have been passed. In this case, we can see that it was Gary Johnston of Team America who issued this confidence level, so if we have a problem with it, we know who to call. That's all there is to the data object, really. Some event types contain more information, some less, but as a rule, they are kept small and succinct. This is because the expressive power of Eiffel is not in the individual event, but in how they reference one another. This brings us to the links object, which is actually an array. Every event has one, and the syntax is always the same. The array contains any number of objects, with each object constituting one link to another event. The type property refers not to the type of the event, but the type of link. and for every event type there is a set of valid link types. In this case, there are two causes for this event, and there are two subjects, subjects being what this confidence level actually applies to. Perhaps two artifacts making up that login service of yours. The final one is sub-confidence level, which can be used in case one wants to aggregate confidence levels. As an example, a confidence level ready for release might aggregate the confidence levels acceptance test, performance test, and stability test. The target part of the link is the ID of the event you are referring to. This means you always link to something that already exists. In other words, you link back in time, which means Eiffel event graphs are always acyclic. Similar to other properties, many links are optional. You don't have to declare sub-confidence levels if you don't want to, and you don't have to bother with causes if that doesn't make sense to you. Start simple and small, with the event types you need and the properties that make sense to you. Then you can expand from there and enrich the graph as you go along.